So the 5.3 lecture, we're talking about rational exponents and roots. So rational exponent would be some base being raised to, let's say, a over b power. The number on top is always the power, and the number on the bottom is always the root. So if we look at the examples down here, if we give you a for the base raised to the m power divided by the n root, so that's what the mn stands for, you can write it of one of two ways. You can do the root and then raise it to the power, or you can do the power and then take the nth root. And roots, remember, something like square root of 9, that means 3. There's an assumed 2 in front of the radical, so it means what two numbers multiplied together will give you 9, so when you take the square root you get 3. People are used to seeing like the cube root of 8. What number times itself 3 times would give me 8? Well, the answer would be 2. Some very common and general examples: x to the 1/2 power is the square root of x. X to the 1/3 power would be the cube root of x. And if I saw x to the 3/2 power, you could write it as the square root of x to the 3rd power, or you can write x cubed with the square root over it. So try to do these without the calculator. If I was going to do 27, just for an example, you could do the cube root of 27. So I can do the cube root of 27 first and then square it. So what number times itself 3 times is 27? Well, that would be 3. Now I can square that and get 9. However, if we look at versus the other one where you go 27 squared and then cube root, many of us won't be able to do 27 squared, probably none of us do 27 squared in our head and then find a cube root. So this is a correct way to write it, but it's going to be much more difficult for us to do in our head. So again, 8 to the power of 5/3. We probably would look at doing a cube root of 8 first and then the power of 5. So the cube root of 8 is 2. Raise that to the 5th power. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. And you certainly could look at this on a calculator to make sure you're getting them correct, but 16 to the 7/4. So again, this is a perfect example. How many of us can do 16 to the 7th power in our head? But maybe if we do 16 and do the 4th root, so again, what number times itself 4 times would give you 16? Well, that number is 2. Now, even though it's a large exponent, we can do 2 to the 7th in our head. 2 to the 1st power is 2, 2 squared is 4, 2 cubed is 8, 2 to the 4th is 16, 2 to the 5th is 32, 2 to the 6th is 64, and 2 to the 7th is 128. What we want to remember when we look at these examples is stacked exponents. So when exponents are stacked, we want to multiply. So I'm going to start with number 5. That's x cubed right here, number 5, x cubed. So you go 3 times 1/3 gives me x to the 1st. But I don't need to write x to the 1st, I can just write x. X to the 3/4 when it's a fraction, so I'm going to number 7. 3/4 raised to the 4/3, again, we multiply. When you multiply reciprocals, you'll get x to the first power, which is simply x. We have to be a little bit more careful with numbers 4 and 6. Because in number 4 and 6, the power here is even. And if the even power is there first, you have to remember to do the square root. So when you take x squared to the 1/2 power, if you were solving this, you'd want to talk about doing plus or minus. But in this case, when it's x squared to the 1/2 power, we're just getting x to the first, or x. But when solving this in an equation, you would want to remember plus or minus. Same thing here, 4 to the 1/4 power is x to the first. You'd want to be thinking about plus or minus x. We'll run into that when we solve some of our equations. So if I were to solve this, I might write it first as x to the 1/3 power is equal to 12. In this case then, I could go ahead and raise it to the 3rd power on both sides. So I'm left with x, and if you do 12 cubed on your calculator, you just type it right in, you're going to get 1728. Again, my x is the base. I see a power of 3 and a 4th root, so this is x to the 3/4 is equal to 11. If I were to raise that to the 4/3 power on both sides, I would end up with x, called the undoing exponent. And then when you type in the 4/3, some of you are going to have to make sure you type in parentheses and divide by 3 just to be careful. But the approximation is 24.46. And the last one, a base of a being raised to the 11/7 power is equal to 21. If I raise both sides to the reciprocal exponent, it undoes my exponent. And if you carefully type in 21 raised to the 7/11 power, again making sure you use parentheses correctly, you get approximately 6.94. And that will take you into the assignment on page 256.